Welcome back to Be Spice. In this session, we'll discuss about a new topic, mastering instrument installation. So this is what I have explained in last video, right? So we are going to have a series of videos on this mastering instrument installation. So meaning it will focus on all the installation aspects. Of course, we have done a lot of, design related to engineering, but basically the detail engineering, right? So in fact, we covered extensively these installation aspects also, but just to make make it short and sweet, like a crispy answers or a crispy concept, right? So I just wanted to give you in a different format, different format as a short notes. So this will be a Bible for mastering instruments installation design aspects. Okay. So as part of that, there are many actually. In fact, one is the installation in control building. See, when we do the installation in control building, what are all the aspects we should watch out for as for the design is concerned? In fact, we have uploaded a video on installation of equipment in control room, cable layout in control room, and also the what do you call the MCT multi cable. If you are interested, you can become a member and you can watch and get benefit. Yeah, that is one part. Then installation of main cableway. So that is the second part. And few more also there, like field instruments installation, like each type of instruments, each type of instruments, what are all the aspects like upstream, downstream, all these requirements need to be taken care. Everything we are going to cover. So basically the blue one is going to be in this session and the rest of the things will be in the subsequent session. Okay. And of course, instrument impulse lines, many of you are aware of this, but still it will be a refresher for you guys. And analyze the sample piping criteria, then heat tracing. I think it's not tracking, it's a heat tracing and insulation. And of course, this instrument as supply piping. This is for the control valve, all these, right? Then instrument pneumatic signal. So this is a piping. This is a piping as supply piping. This is the tubing actually. Okay. Then, of course, the instrument wiring and earthing, all these. In fact, the earthing I'm going to cover here itself. So, yeah, so probably after this, we'll have another 7 to 8 sessions actually. Okay, let's go into the detail. Now, installation in control room building. Okay, so as part of that, what is the first item? First item is equipment layout and installation design. See, friends, if you remember, we have a human machine interface, right? We call it as HMI, right? So this equipment which does not contain a human machine interface shall be installed in the equipment room. Meaning when you are, it's a, like a, panel, like it's a panel, right? Equipment which does not contain a human machine interface, meaning it's like a panel. Okay. So those things we can install in the equipment room. Why? The human machine interface, such as, HMI, right? Operator station, workstation, all these can be installed in the control room. So that is the one of the basic thing. Of course, you know this, but it's a refresher. Okay. And the both room, whether it's equipment room or the control room, should have a free access flooring. That one also we should have. Of course, this is not our botheration, but we need to ensure this. Operator console and printer shall be sit directly on the floor without any anchor bolt. Just like that, we can place it. Okay. That's it. Then equipment in control room shall be bolted onto a steel channel base. Whatever is the equipment which we have seen, right? Layout of equipment in control room earlier, right? So those equipment shall be bolted onto a steel channel base which shall be fixed to the floor with anchor bolts. This is one of the topic. And of course, the fronts of the DCS, the front side of the DCS and other equipment in equipment room shall be aligned, meaning it should be flush. The panel, when you look at the after installation, when you look at in front, it should be flush. There should not be, one panel in front, one panel on back side, those things. Okay. So these are the some of the aspects we should watch out for. Equipment layout and installation design. And of course, few more to add on. Clearance between each line of equipment shall be at least 50 mm when all opposing doors are open at 90 degrees. Just remember, two rows of panels we are going to mount. So when we open both the cabinets, there should be at least 50 mm, gap actually, right? When the door is open, 90 degree. Okay. So of course you don't know, you all know this, but this is the guidelines actually, right? Then operator consoles in the control room shall have the following free space. What is that? Minimum 2500 mm at front side. Okay, when you go and stand and operate. Okay, then same 1500 at the back side on the wall, back side of this. Okay, so this should be adopted. So this is one aspect, equipment layout and installation design. Then second, wiring in control room. Wiring in control room. Okay, right. So in the wiring in control room building, field cables, meaning the home run cables, home run, the multi-pair cable, right? Yeah, shall be terminated in marshalling. You know, right? So the field cable coming to the junction box, and from junction box, it goes to the marshalling. That's a multi-run. I'm talking about the multi-run. Okay. So when special cables are required or splicing of cables is prohibited, the field cable shall be directly terminated at the designated instrument. Direct cable is okay. Earthing buses for earthing of equipment shall be installed under the floor. Any earthing also, all this should be under the floor. Okay. Since we have covered the earthing here, I also wanted to touch upon a bit. Instead of covering in a separate module, I want to touch upon a bit here. You know, safe earth, right? That is for the panel board, right? Though the resistance should be 100 ohm or less. Shielded earth on your system earth. This is 10 ohm or less. Intrinsically safe also safe, 10 ohm or less. Okay. So this is safety. This is the system instrument here. Okay, friends. Right. I hope this is okay. Then also the earthing wire for 600 volt grade PVC insulated wire of 1.5 square mm or larger. Okay. So that should be used for this one earthing minimum. Of course, you have to follow your project spec also. Then color should be green or yellow. Okay. So this is just a basic idea. Okay. This is about the wiring in control room. Okay. Right. Then now wiring in control room building, few more actually. The cable entrance to the control building shall be fully sealed. If you remember the MCT, yes. Well, the cable going into the MCT, we have sealing, right? Yes. So the cable entrances to the control building shall be fully sealed to prevent the propagation of explosive gas or vapors or ingress of liquids. Okay. So this is the look and feel. As you can see here, this is the ground level. Okay. So if you see here, the cable tray is coming here. Okay. So this is the wall actually. So this is all outdoor. This is the indoor wherein we have the cabinet and all, right? Yes. So this is where actually you need to seal here. You see here, you have to seal here. Okay. So this is a cable coming in and going through this. Of course, here the MCT will be there. All will be sealed, friends. That's it. Okay. Right. Good. This is about that. And of course, wiring shall be segregated by routing or by using separator. I don't know whether you remember. See, if a power cable and of course, ideally power cable and signal cable to be separated, segregated in a separate tray with a spacing of, 300 mm. Okay. In a tray, if you do the separate tray. But in case if not possible, then in the same tray, you can segregate this using a separator. Okay. So that one I covered also in the layout of cable tray. You can watch and get benefited. Okay. I'm not going to cover that here. Okay. Then main cableway system. Main cableway. An above ground cable tray system shall be used for the main cableway in the plant and to the control building from the plant. So basically how you are bringing the cable, that's what I'm saying here. An above ground cable tray system. So cable tray will be coming in the pipe rack, then you go into the control building. So it's on the tray. On the cable tray, the above ground basically. Okay. And of course, in some cases, if it is not possible, then you follow this trench routing. Okay. So that is the point. Then design of cable tray. See, cable tray shall be sized to keep the total cross-sectional area of the cables equal to or less than 50% of the interior cross-sectional area of the cable tray. So basically, when you size a tray like a 300 mm tray, So you should ensure that 50% of the interior cross-sectional area should occupy. So the remaining should be space, it will be span, okay? So that should be the criteria. So you should size the cable tray in such a way. Of course, I'm going to cover that sizing of cable tray also in a separate session. Let's see later, okay? And as a rule, all cable trays shall be located on the process pipe rack. This is what I just explained, on the process pipe rack, away from also equipment such as pumps, furnaces, which are possible ignition sources. We should always keep away from these ignition sources. So this is about the design of cable tray. Then cable tray shall be supported at maximum of interval of 3 meters. Every 3 meter you should have a support actually. And it should withstand a minimum load capacity of 1.5 times the cable tray and the cable weight. So you should calculate this, okay? And of course, we have to specify this to the vendor. Okay. For example, if there is a possibility of a human, person need to step on that, then we have to add an extra 50 kg on this. That is the thumb rule. Okay. So this is about that. And of course, yeah, if straight run of cable tray exceeds 50 meters, the straight run of the cable tray exceeds 50 meter, cable tray shall have at least one loose joint. What for? To observe thermal expansion, and this joint shall have a jumper lead to maintain the electrical continuity throughout the cable tray. You would have seen, right? See, there should be a loose joint, obviously, when it exceeds 50 meters. Okay. The main point is we should have a jumper lead between these two loose joint to maintain electrical conductivity throughout the cable tray. Okay. So this is about the cable tray. Right. Now, few more to add on. So there is also cables, right? So I am classifying these electrical circuits in two groups. One is the measuring, other is the other circuit. So under measuring, as you know, we have 4 to 20 milliamps analog signal, thermocouple signal, RTD signal, digital, intrinsically safe, pneumatic signals. And other circuits, we have a power for solenoid valve and other application and contact signal. And of course, the power circuits and the pneumatic signal. So you can group this pneumatic under measuring circuits or under other circuits. Okay. So this is all the electrical circuits and classification of signal which need to be adopted. Then now we have seen the signals all. Now material. Cable tray shall be ventilated trough type. We call it as a perforated tray, right? Yes. See, that is one way. Instrument tray is always like that. In some cases, we also go for a galvanized steel, right? Yeah. So using prefabricated, or we can do the fabrication at site also using a mild steel angle, and channels. Okay. Cable tray shall have a metal cover. If multiple cable tray layers are used, I'm talking about the galvanized, the perforated tray, GI tray. So if the cable trays, multiple layers of cable trays are used, the uppermost tray shall have the metal cover. Cable tray shall be as per the project requirements, material basically. Could be aluminum or steel or SS or fiberglass. Okay. Shape of the cable tray, we'll leave it to the manufacturer stand. Okay, friends? I think this is okay, right? Yes. So that's all actually about this session, because I want to break this session. I don't want to, make you boring. So I just want to break this session. And the next session, I'll talk about the important topic, mastering instrument. We'll focus on the field instruments. Okay. Thanks for watching and take care. If possible, share with your friends also. And if possible, you can also, subscribe. And if possible, you can become a member so that you will not miss any important videos related to instrumentation detail engineering. So far, we have uploaded around 251 videos, all related to instrumentation detail engineering, meaning whatever you guys are doing in your engineering company, right? EPC, yes, it's not a gimmicks or it's not something, like a fancy things. This B-Spice is only for detail engineering. Okay. Thank you. See you in the next video. Bye.